Today we are solving reverse match index 4. In this question we are given a string S of lowercase English letters. For every character at index I, if there is a character at index j such that j is less than I, and that character at index j is a mirror of that character, we have to add the difference of their index to the score. So what is a mirror? A mirror is basically the alphabet when the order is reversed. So for example, A will become Z and B will become Y. So we need to do this processing until we have reached the end of the string. And at the end, we just need to print the result. That is the score. Let us look at the sample test case. So for this string, we can see at index I don't have any character less than index 0, which is the mirror of A. So I'll move forward. Still, I don't have any character at index 1. But at index 2, I have Z, and I know that A is the mirror of Z and it exists before Z. So I'll add the difference, that is 2, to the score. Then again at index 4, I have X and I have already encountered C. So I'll add the difference to the score and the final answer will be 5. Let us look at how we can solve this problem. Now let us look at the different ways that we can solve this problem. The first and the most obvious approach is the brute force approach. The main idea here is that at every index, I will be checking for the mirror character to the to the left of that index. That is till the index 0. If I am able to find any mirror character, I will just mark them and store them in another data structure. And I'll keep doing this until I reach the end of the string. So since it involves a nested loop, the time complexity is big O of n square. And as we are using extra data structure to store the marked elements, so the space complexity will also be big O of n. In the optimal approach, we are using an unordered map in which the keys, the ASCII values of every character is used as key. And for the value, we are using a stack in which we are storing the indexes of the characters. So we will traverse over the string, and for every character Si, we'll calculate the mirror index for it and check if the stack has the mirror present already or not. If it does, then we'll just pop it out, calculate the differences, and add that to the score. If it doesn't exist, then we'll just push the current index to the stack. The time complexity will be big O of n and the space complexity will also be big O of n. Now let us look at this approach in detail. So I have taken this sample string. In the start we need to iterate over the string. So we will be at index 0 in the beginning. First we need to check for the mirror character, which is given by this equation 25 minus this part. Keep in mind that I am using the reduced ASCII value, not the absolute ASCII value. That's why I've written this minus 8. So for lowercase a, it will correspond to 0 instead of 97. Similarly for b, it will correspond to 1 instead of 98. So for a, I need the mirror character z, but my map, I don't have anything, right? These are the keys and these are the values, which is a stack. So I don't have anything in my map. So I'll proceed to step 2, which is to insert the character in the map. So the character is A, which corresponds to 0, the ASCII value, right? The reduced ASCII value. So I'll insert 0 as the key, and for value, since I have the stack, so I'll insert the index of A, which is 0. So I'll insert 0 into the stack. All right. So we'll now move to index 1, which is C character. Again, I'll calculate the mirror character, and it doesn't exist. I'm looking for 23, but I don't have it. So I move to step 2, and insert the character into the map. So I'll insert the character, which is 2 in terms of reduced ASCII value, and I'll insert the index as well, which is 1. Again, move to index 2, find the mirror character, which is in this case A, and I have A here. As you can see, 0 here represents the A. So for A, I have the index 0, which is the closest, because on top of the stack we will be having the closest index, right? So I have 0. So I'll pop this out, add their difference, that is 2 minus 0 to our score. So our score is now 2. And of course I'll be adding this. So 25 will be added, and this is at index 1. So I'll add 1 here. Sorry, 2. Now let us move to the next index. Index, alright. So now we are at index number 3. Again we have 0, and I'm looking for A. I do have A in the map, but as you can see the stack is empty, so I don't have any index that I can use right now corresponding to A. So I can't add to our score. So I'll just move to step 2. Step 2 is inserting the character. I'll insert 0 Z again, but this time the new index, which is 3. I'll move to the next index, which is 4. I have character X. I want the mirror character C, and I have it already present in my map, which is 2. And 2, for 2, I have index 1 in the stack. This uses the closest. So I'll pop this out, calculate the difference, which is 4 minus 1 gives 3, add it to our score, and then, of course, add this character into our map. I'll add 23 at index 4. And now we are at the end of the string, so we'll stop here. And by this point, we have calculated our score, which comes out to be 2 plus 3, 5. One thing that I forgot to mention is as soon as you find the mirror character, so you won't be inserting the index. So since we for this Z I had A encountered, I will not be inserting 2 here. Similarly for this X I had C, so I won't be inserting 4. This is because these are marked, right? So I can't use them again. So I won't be inserting into the map. Okay, let us look at the code now. So we are using the unordered map to store the character and the indexes in the stack. We are iterating over the string in this loop. For every index, we are checking if we have encountered the mirror character or not. If we have not encountered it, we'll just insert the current character into the map stack. Or else, if we have present, we'll just calculate the score and add it to our answer. And then we'll keep moving this until we have reached the end of the string, and at the end we'll just see out or return our answer.